All right, it's recording. Let's have a look. 6E and 6F, how are they different? 6E is very similar to chapter 3 where you're finding the turning point. So 6E is like your turning point for quadratics. Do you remember quadratics where I gave you a bracket x plus b squared plus k or c, whatever it was? And I told you up, down, left, right, thin, wide. Same thing with cubics. Right here, this is your original equation for a cubic, meaning the most pure form of a cubic is literally this. Y equals x cubed. Okay, so if you didn't do anything to it, didn't move it left or right, just cubed x. This is what cube of x looks like. X squared, on the other hand, looks like that. And the reason why that happens is because when you square a negative, it always goes positive. That's why it never drops down the negative region. But cubing, when you cube a negative, you do get a negative value. That's why it looks asymmetrical. Why do I say asymmetrical? Because when you say 2 cubed will give you 8. But then negative 2, when you cube that value, you get the same number, but just in the opposite direction. So it'll be negative 8. So it's asymmetrical. Okay, that's the difference between an even power and an odd power. When you do an odd power, you'll get that asymmetrical property, right? So this is what it looks like. Now, just like a turning point in a quadratic, this one isn't called a turning point. This specific spot here, the center, is called an inflection point. Write this down. That's called an inflection point. Now, I know the ones that we just drew before in 6F, we drew, it looks like an N shape. True? But the reason why the N shape occurs is because you have 1, 2, 3 x-intercepts that are possible. But that would mean that you have 3 different brackets. That's why you have 3 different intercepts. Look at this one. This one only has 1 bracket. But if it only has 1 bracket, that implies only one thing. There's only 1 intercept. There's only one way to draw this N shape with 1 intercept. Can you see that? Instead of crossing 1, 2, and 3, it goes 1, and it just goes back up. This is where you only get 1. And that's what we're going to be analyzing in 6F. How many ways can you draw a cubic graph? And here's a couple of ways, which I'll show you in 6F to copy down. But this is your original graph. Crosses once. Looks like an N, but I just made sure it only touches once. If I wanted to touch twice, you can have a cubic that touches twice. This is how it would look like. Crosses once. As it comes back down, instead of crossing through, it's like a turning point there. That has 2 intercepts. And the one that you've just been doing has 3. 1, 2, 3. Whoops. Can you see the difference? Each one all looks like an N. It's just how many intercepts you have. So this one only has 1 bracket. So it's cubed to tell you it's a cubic graph. There's only 1 bracket, so 1 intercept. This one, which is special, this is in 6F, which I'll show you in the notes soon. This one you just learnt. This one you did where you had 3 different intercepts. It has 3 different brackets. But if you think about it, this one is linear, 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 meaning x times x will get you cubed. This one, if you cube the x, you get the x cubed. Here, the only way to have 2 brackets and get a cube, one of it has to be linear, but what's the other one? X times what will make it a cube? What would this one have to be to make it a cube? Yeah, this one has to be a quadratic. If you have a quadratic factor, this is called a quadratic factor, it means that this number here has to be only like, for example, I put minus 2. That means you cross out x equals 2, but it has to be doubled. It has to be, when I say doubled, what I'm trying to say is x minus 2 times x minus 2. It's the same bracket. And then that's your, I don't know, x plus 1, for example. Let's just make it a x plus 1. This here will have a turning point at x equals 2. I'll show you. If we go to Desmos right now, and hopefully you understand this idea because this is 6F. 6F talks about all the possible graphs you can have. So watch. Y equals. Now, if I want the x-intercept to cross at, let's put on the axis numbers. Let's say I want the x-axis intercept to cross at -2. So I want it to cross through -2. What should be in the brackets if I want it to cross at -2? The bracket should have x what? If I want it to be -2, the x-axis intercept to be -2, if x equals -2, what should be the brackets? X plus 2. Crosses through, right? But that's only one bracket, so that's why you get linear. But if I wanted a cubic, you told me just now it needs to be a squared. Can you see, as soon as I put a quadratic onto that second one, I have one intercept and a turning point. But where's the turning point? Turning point is on where x is. X is equal to 0. If I want to make that curve at 2, change that. Wherever you put in square. So watch what happens when I put a -2 in front of it now. Can you see how if I put a -2, it crosses through because that's a linear factor. That's called a linear factor. This is called a quadratic factor because that's a quadratic. But if you solve for that, x minus 2, if you solve for x equals 0, x equals 2. 2. That's why it has a turning point at 2. If I wanted to switch it around, if I wanted to have a turning point here, but then crosses through 2, I flip it around. So I take off the square. So take off this square over here. If I took off that square, and then I put the square over here instead, I got to delete this little power. See what happens? Still an N shape. Still N. Well, what's the difference? It turns at -2, but then it crosses through 2. So how do you know that you're going to get this shape? It's based on the number of brackets. 2 brackets means 2 intercepts. 1 bracket means 1 intercept. 3 brackets, which is what you were doing, you get 3 intercepts. Does that make sense? So if you look at your exercise 6F notes now, let's have a look at 6F. So flip a bit forward. These are all the possible graphs that you can have, but I don't want you to teach you to memorize the equation. I want you to read the equation. Let's read this. This x cubed, how many brackets do you have there? I know I didn't put them in the brackets, but if you were to write brackets, how many x-intercepts do you expect this one to have? It's only 1. Because another way of thinking about this is a times x cubed. That's what that is. 1 bracket. This one should look more like this. Draw this in. Should look more something like this. Okay, so 1 intercept. Let's look at the next one. How many intercepts do you think this one's going to have? 3. It has 3 brackets, and they're all at different points. One's at B, one's at C, one's at D. So I expect the graph, if it's a positive graph, if A, the number in front of all the cubes, is positive, I expect it to look something like this, where you have it at x equals -B, x equals -C, and x equals to -D. Yeah, just like how you normally solve them. Right? So then -B, -C, -D should give me the x-intercepts. Let's have a look at another type. What about this one now? How many x-intercepts do you expect this one to have? Third one on the bottom left corner. 2, because there's only 2 brackets. But one key thing you have to look for, if this is going to be 2, one of it's going to be quadratic. That's the quadratic one. So your turning point should occur at x plus b, or whatever x equals b is. Okay? There's a turning point in here, and it crosses through that one. So here's an example, because this is a new one. Here's an example. For example, if I gave you y equals to x minus 1 squared, x plus 1, what do you expect? Where's the x-intercepts at the moment? For the first bracket, x should equal to 1. Very good. The next one? -1. Very good. So I expect -1 and 1. There should be intercepts here. But this is a cubic. Now clearly this is going to be a positive graph because x squared times x is going to be a positive x. So I know it's going to look like an N shape. But at 1, I've got a square, so it has to be a turning point at 1, but crosses through at -1. How do you draw this N shape so that you cross through at -1, but have a turning point at 1? There's only one way to do it. Have a thing, picture it, and hopefully if you've got the picture, it should look like this. Cross through -1, comes down, touches 1, comes back up. Can you see that? That's the skill that I want you to take. It's not about memorizing the equation. It's about reading the equation. Okay, because then you can adapt. You can adapt to the problems. The last one. We don't know. The last one I don't know. Sometimes it has 2x intercepts. Sometimes it has 1. Sometimes it has 3. The only way to know is you have to factorize this. And that's what you just did. So the sheet that I gave to you at the start of this session, I gave you ones that actually had 2, but not all of them always has 2. So the skill in 6F that I want you to take there is you've learned how to sketch. These ones are just variations of them. But knowing how the end shape can change based on the number of brackets is what 6E and 6F wants you to do. How's that as a summary? Yeah? So as you practice 6F, I want you to train here, but you know that there's a variety. Then you have to know which shapes you're working with. To finish off the content, before we look at your formative test, and then you write a reflection on your progress. Yep. Oh, yep. Yep.
Do you always put positive 0 in that gap?
Yep.
So it's never negative 0.
Oh, well, whether you put a positive 0 or negative 0, it's going to be the same because you times it by 0, it doesn't matter. It changes. So, for example, this one, if I were to do the polynomial division way, you would have had x minus 2 on the outside, 10x cubed minus 21x squared, and then you got a plus 4, yeah? That gap, you can put in plus 0x. But whether you put a plus or a minus, it doesn't matter. And the reason why is this. See, as I cover through, let's say I put a minus instead, right? Let's put a minus for the sake of it. If I times it now, 10x squared times that will give me 10x cubed. 10x times that is minus 20x squared. Take away, that gives you 0, and negative 21 plus 20 is negative x squared. Now, as you drop this one down, see how I kept it as minus 0 instead of plus 0? Still doesn't matter, because by the next line, I would then say you need to times it by minus 1x to get negative x squared. But then negative 1x times this is positive 2x. Now in this step here, you see whether it's positive or negative, it doesn't matter, because essentially I'm saying negative 0, which is the same thing as 0, take away 2. So if you think about a number line, 0 is here. Whether it's positive or negative doesn't matter, it still stays in the same spot. And then you're saying minus 2, you're still going to get minus 2x. And then you drop this one down, and then you continue the last step, which is, what do I multiply to x to get minus 2x? Minus 2 is there, so minus 2 times that is minus 2x, and minus 2 times minus 2. So you still get the same. So it doesn't matter if that's plus or minus, on the number line, you'll still be the same. Yeah. Okay. All right, team, can we turn back to 6E? 6E, the notes that I just gave you, so that remind your up, down, left, right from quadratics. Let's look at 6E. Remember this turning point form that I showed you? Whoops, it's taking a while, it's a bit laggy. All right, here we go. So you know this is what a cubic graph looks like. There's only one bracket, so there should only be one intercept. H, K, and A, let's remind ourselves. Which one is responsible for up and down? Which letter? K. If it's positive, goes up. Negative, goes down. X minus H, what is that responsible for? Left or right, but there was a technique I taught you. Good, let A equal to 0. So remember I taught you to let X minus H equal to 0. Don't question it for now until I teach you transformations later on. Right now, just memorize that. Let A equal to 0. If H is positive, goes to the right. If H is negative, goes left. That's exercise 3D from memory. Okay, so 3D was quadratics, but now it's cubics. And last one, A. If A is positive, instead of smiling, now you have positive graph. If A is negative, then you have a negative graph. It's like an inverse of an N. Okay, so one looks like an N-ish shape, and the other one is the upside down N. The other numbers are still the same. The larger the number, the thinner it is. Okay, so it gets thinner and wider. Copy those notes, because then we're going to test on Desmos so you can visualize, and that's it for today's lesson. Okay, so really I wanted you to take out how do you do 6F normally, what are the variations of cubics, and then reading a turning point form or inflection point form. Okay, here we go. Let's have a look at Desmos. I'm going to delete this now. Y equals, here we go. I'll put an A number 3 times x minus 1 to the power of 3 plus 5. Can you see the inflection point goes up by 5, to the right by 1. If I try to figure it out now, to the right by 1, up by 5, that is where my inflection point is. So if I put in 1, 5, there it is. Still the same N shape. The 3 doesn't matter. It's just positive. If I put a negative in front of 3, it's the other way. But the inflection point is still the same. So everything I taught you from 3D can be applied to 6E. Same idea. When you're sketching these, obviously you're going to find the y-intercept and x-intercept. Same thing. Let y equal 0, let x equal 0. Okay? But I'm going to stop there just because I know it's a lot of info so far. But if you could do the first sheet that I just gave to you, that's the skill. Build that skill first. We'll do more of this next week. Okay, so I'll give you more graphs. I'm going to give you a variety for you to practice to be able to sketch any type of graph. Let's start off with 6F. Okay? Give you a bit of a break before, I'll give you maybe another, let's give it about 4 minutes break just to take a breather, copy some notes, or take your time to think. Then I'm gonna hand out your quiz. We're going to go to the last page because we've marked for 3 out of 4 pages. Just the last page. I'll just go through the last solutions with you. And then I want the remaining time as you go into compass, go into progress, and then type of reflection. Okay? Yep. Let's go this one.
Yeah.